Up next, we have Trevor McDonald on monitoring the physical world with Nagios and Arduino. A little bit about it is supporting technician. Yeah, well, actually, I should say, Trevor is a support technician at Nagios, and this topic will show a few examples of physical environment monitoring reported passively for Nagios. Ladies and gentlemen, please put your hands together. Trevor McDonald.
Thank you, everybody. Can everyone hear me okay? Good. So, as you can see, monitoring the physical world with Nagios and Arduino. One of those names you should recognize is Nagios. If you're not familiar with Arduino, it's okay. I'll explain that all. I'd like to start off with who am I? As was mentioned by the MC, I'm a support tech at Nagios. I've been there about a year. Actually, last year I was there for 2 weeks before I got sent off to the conference, which was an awesome time because I didn't have to do talk. So this is my first talk I'm doing for Nagios. On the forums, if you're on there at all, I'm T. McDonald. I'm one of the 5 people that you'll see on there pretty often. On the team, aside from support, I do a lot of documentation, bug testing. I am one of the people crazy enough to actually deal with Perl. A lot of people say it's very ugly. I happen to enjoy it. Other things I do outside of support, you've probably heard me around the conference speaking Spanish with a few of my friends. I love world languages. If you speak any other language, I'd love to talk to you. I think it's just a great thing to have a conversation in another language. You really get to know people. Computer security, I'm a big fan of the DEF CON conference out in Las Vegas. It's a weekend-long security conference and all sorts of really cool, really good way to stay on top of things and kind of learn the latest attack and defense, kind of keep your environment safe. Electronics, obviously, brings us into our talk today. I like taking things apart, hopefully putting them back together so that they work again, or just modifying them. Currently, my coffee machine is hooked up to the internet. Remains to be seen if that's a good idea or not, but we'll see in the following weeks. I added this slide kind of last minute just because I definitely kind of push Arduino in this talk. I want to mention I am not affiliated with Arduino. I am just a huge nerd. That's it. I like the platform. I really enjoy what it can do, but I'm not getting paid to be here. Any images that show up in here, obviously, legal disclaimer stuff. I'm also not Iron Man yet. Hopefully one of these days I'll have like a full, battle suit, but gotta start somewhere. So, the point of this talk, and to kind of expand on the title of it, is monitoring the physical world with Nagios and Arduino. So you should all know what Nagios is. Maybe you've heard of it if you're here. Let's define a physical monitor. So a few months back, we had a customer who said, okay, can Nagios monitor a burglar alarm? I thought about it and I said, well, yeah, if the burglar alarm has an API that you can query, potentially you could. And I started thinking about, well, let's just build our own burglar alarm. And that's kind of how this talk came to be. So a physical monitor is different from the usual things you would monitor. SSH, ping times, number of running processes, CPU load, things like that. Physical monitor, it could be like the temperature of a room. If you're running a data center, you'll want to make sure that it stays kind of in that zone where it's not too hot, not too cold. Along with temperature is humidity. You could have your temperature spot on, but if your humidity is 80%, you've got a problem. Huge problem. Light. Maybe you're doing some sort of application with like farming, right? You might want to make sure that your plants are getting enough light. And if they are not, you can take corrective actions. Motion. Light and motion could go together for a security system. So if somebody's not supposed to be in a certain zone in your data center between the hours of 8 p.m. and 5 a.m., right? You'd want to know that. And the one I'm specifically going to talk to today kind of ties into the security. It is the open or closed status of doors or windows, right? And I'll kind of go into this little blinking ball of wires here later, but we're going to specifically focus on that today. So how do we do that? There are a couple of existing solutions which are great, but they have their flaws, and I'm going to kind of talk about the pros and cons of each. A lot of the existing solutions are closed source. You don't really have control over the hardware or the software. Maybe there's some sort of functionality that doesn't exist that you would like to add in. You can't necessarily do that with a closed source system. It's got very limited scope. The best temperature sensor in the world could give you like 1/100 of a degree of Celsius, but if it doesn't give you the humidity as well, you could have a problem that you just aren't aware of. And a lot of the solutions currently, they might do that, they might not. If they don't, you can't really expand upon them. Expensive with an asterisk. I didn't go out and compile a big Excel spreadsheet and do the average and take out the outliers and all that. But a lot of the solutions I found were like $1,000 plus. And maybe you're a small shop, you don't need that. Maybe you're a big shop that needs a lot of these things and you can't justify that cost. Now, I put the asterisk there because the models that cost about $1,000 or more, you are getting a lot of features. I'm not saying that they are overpriced. They are definitely worth the money. But sometimes you just can't pay that cost. So the solution I'm proposing is to use the Arduino embedded platform. Kind of as counterpoints to all those is they are 100% open source. There are many, many revisions of the Arduino platform, which I'll kind of go into detail later. Both the hardware and the software is completely open source. You can change it, modify it, delete whole chunks, and this whole community has kind of popped up around building bigger, better boards or customized to certain needs. So the beautiful thing about it is if it doesn't do something that you want, you have the power to change that, right? If I find out that I want my window sensor to also detect tilt, so maybe it's not a window that opens like this, it's one that opens like this, you could detect tilt. It's very, very easy to make those changes. And the last counterpoint is that they're fairly cheap. The boards themselves range from anywhere to $5 to $50 on average. Of course, there's some other hardware that you would need to have in addition to that, whatever sensors you decide to hook up, the cabling. But a lot of those things might be things you just have sitting around anyway. So I've talked a lot about Arduino, but what is it? If you're here at this talk, chances are you're either very curious or you're very interested already and you know what it is, but we'll just kind of do a little bit of a review. The thing I have sitting up here is called the Arduino, and it looks like this. It is the Uno revision, which is one of their earlier models. I believe they're on revision 3 currently, and has the following features. It's got a little 8-bit microprocessor. That's that little grayish black rectangle you can see on the bottom. 32K of flash memory, folks. We're talking like a big text file. 2K of RAM, right, for all your variables. A 16 megahertz clock speed. And it runs on 5 volts, or optionally, you can kind of boost it up from 3 volts. It's very versatile. And so essentially, what sets it apart from being a very small, unimpressive, underpowered computer is that it has these digital and analog I/O pins. And those are along the top and the bottom, those rows of little squares. And essentially, what those let you do is provide some sort of connection to the physical world. And I'll kind of go into a little bit more about what those do, but I would like to make some fairly light assumptions before we continue. Excuse me. First assumption is that you know a little bit of C and C++ or any programming language in general. This is not a code-heavy talk. You don't need a master's thesis for this talk. But being able to read code and understand at least logical workflow will definitely help. Passive checks, fairly prevalent in the Nagios world. If you don't understand them, basically an active check is where Nagios is doing the checking. Passive is just where a device is sending it to Nagios. This is kind of a reverse workflow. The solution I present today uses passive checks. It could certainly be extended to use active, but for the demonstrations, I thought passive was a little cooler. The last assumption is that you understand the following incredibly complex logic. You flip a light switch up, the light goes on. You flip it down, the light goes off. If anyone would like to demonstrate, we can certainly do a live demo, but I don't think it's necessary. This is also called digital logic. Everything in the digital world, as you know, is on or off, 1 or 0, up or down. The light is lit or it is not. Fortunately, that's very easy to work with in the embedded electronics world, not so easy in the political world. We can talk about that later. So how does this solution work? Well, the pins that I have, the GPIO, General Purpose Input Output. You attach hardware to the pins. Now, hardware could be anything. It could be a motor, it could be a light, it could be a button. It's anything physical that you can touch. And because it's general purpose I/O, each pin can either read or write data. So reading could be like if a button is pressed or if a switch is opened or reading a temperature sensor. And then writing would be like turning on an LED or maybe you have some blinds that you'd like to automatically raise and lower. You could attach a motor. You could do a very annoying buzzer. So pretty much anything that's input, output, or both, some things are both, can be attached to one of these pins. They can be configured for either task, so you can switch dynamically in the middle of your code, right? Okay, I don't want this thing to read anymore, I want it to write. Usually you won't do that because if you have a button, there's really no reason to make that, treat it like an LED. But it's just regular old C code or C++, whatever you prefer, is used to control the pins, so determine if they are input or output. And if they're input, C code is used to read them, or if they're output, it is used to control them. So a simple example of how a blink might be set up. So you just want to blink an LED. That's kind of the equivalent of hello world for Arduino. So you have all these pins, and I apologize, the picture is a little bit blurry, but the red wire is going to 5 volts, so it's supplying power. And then it kind of travels along to a little resistor because you don't want to blow up your LED, put too much current through it. Goes through the LED, comes back to through the purple wire, which is labeled pin 13. All the pins are labeled 0 to 13. There's a couple analog pins, which I won't really talk about too much in this talk. But the digital pins are the ones we care about. They're 0 or 1. So essentially, the code for this is very, very simple. Up at the top, you define an integer called LED. You really call it whatever you want. I just call it LED to keep it short, and we give it the value of 13. There are 2 function blocks here, setup and loop. Setup is run one time, and that's it. Loop is continually looped through. It's like a while that runs as long as there's power. So the setup function does one thing. It runs the pin mode function, which sets pin 13 to be output because we want to control what it does. It's an LED. The loop is then run forever, and it essentially only does 2 things. The first thing it does is digital write, because this is a digital pin. It's a 0 or a 1. Digital write to pin 13, we're going to make it high or 1 or on, or in this case, lit up. Then it's going to delay for 1,000 milliseconds, which is 1 second. And then, if you're still following me, it'll do digital write low, or 0, or off, or in this case, not lit. And it will delay for another 1,000 seconds. Milliseconds, actually. 1,000 seconds, we'd be here a while. And it'll loop forever and ever and ever until XL cuts your power off because you're blinking an LED. So, what does this look like? Look at my amazing GIF. I had a video. I don't know where the video went, but it essentially looked like this. Do not be confused because this is red and this is green. Do not adjust your television sets. But that's all it would do, is it would blink on, off, off. And truthfully, that LED isn't even really necessary because for testing purposes, the Arduino board has an LED on it already attached to pin 13. So this was just kind of showing you the wiring and how everything would be set up. So that's all fine and dandy, but what if we want to read some input? We'll go to that next. Study. I'm going to take a drink. So we've complicated things only slightly more. We have a button. So the blue wire goes to digital pin 7, and the yellow wire goes to digital pin 3. And then there's power kind of run through that. The black is going to ground, which just kind of completes the circuit if you've done anything with circuitry. Batteries, you know, there's a positive and a negative end. Now the code doesn't precisely line up with this because the pin numbers are a little bit different, but the concept is still the same. We, again, up at the top, we have a button pin for pin 2 and an LED pin, again, for pin 3. We have a variable called button state, which just determines is this button lit or not. For the setup phase, again, we're going to set pin mode LED pin as output because the LED is what we're controlling. I'll go ahead and pose for the camera like I'm saying something interesting. There we go. Pin mode button pin input because we want to read the button. It is input. It's doing something interesting. And then we go back to our loop, right, which will run forever and ever. Button state is the first thing we set. It's a variable. We want to determine the state of the button already. So we run the digital read, which is a new function. Very simple. If the button is pressed, it returns a 1. If the button is not pressed, it returns a 0. On or off, 0 or 1, digital logic. Then it goes down to say if the button is high or on or 1, then we're going to digital write the LED pin high or 1 or on. Otherwise, we're going to turn it off, low, 0. Now you might be wondering, why can't you just put the LED pin right in series with the button? Because that's not as interesting. I don't know. And this is what it looks like. Again, 2014, folks, a 2-frame looping GIF. You'll notice the LED is back to red on this for consistency. And again, I had a video of this. It looked very similar. And essentially, that's all it is. It's just detecting the input, the button, and affecting the output. Right? So we're able to read the state of a button or a switch, temperature sensor, whatever, take action accordingly. In this case, we light an LED. Maybe we want to spin a motor to raise our blinds or play a very annoying screech to get the cat off the counter. What we want to do, and is kind of the crux of this talk, is that we want to alert Nagios. We don't just want to take action all on the Arduino itself, which it is certainly capable of doing, but we want to know about it. What good is a burglar alarm if you don't know, right? So how do we really do that? We need some sort of bridge in between the hardware, which is right here, and the Nagios system, which we need networking. We need HTTP for the NRDP, passive result, right? So how do we do that? A little digression, some Arduino terminology here. There's something called a shield, right? And a shield just sits, it connects right up on top of the Arduino itself, okay? And so there are a couple examples. There's the relay shield, which if you're dealing with 120 volt kind of higher powered devices, maybe you want to turn on a washing machine as opposed to a coffee machine. You don't want to mix the high voltage of the washing machine with the low voltage of the Arduino. So a relay is just a way to very safely switch on and off that high voltage. You might have an MP3 shield, so maybe you're making some sort of project that you want to play music or talk back to you. Big fan of Iron Man, if you've ever seen that. Jarvis, his sort of talking assistant. You could pay some British person to record a very charming voice, Dave. LCD and buttons if you want to have UI functionality. So you could have 4 buttons up, down, left, right, 1 in the center for enter, and maybe an LCD screen that allows you to build a very rudimentary menu system. The one we're going to focus on today, however, is the Ethernet shield. And I'll show you a picture of that very briefly. It contains a little chip on there that handles all of the low-level details, so you don't have to build packets by hand and all of that. It handles all the low-level detail interfacing with the hardware. Right? The other beautiful thing about them is that they are relatively cheap. $30 to $60 on average. Now, that might sound like a lot because the board is $25 and the shield is $30. But if you compare that with some of the other solutions out there, especially with the kind of open source nature of this, you're really getting a lot out of it. The other thing is that, as kind of a auxiliary benefit, is that instead of having to do all of that code on the Arduino itself, which does have fairly limited memory utilization, you can kind of offload that to the board itself, the shield, which will take care of all that for you. It has its own RAM, it has its own CPU. So it looks like this. You can see along the top and the bottom you have all those circles. Those essentially correspond with the pins, the general input-output pins on the Arduino, and it just goes right on top. And off to the left there, you can't really see it from the side, but that is the RJ45 or the Ethernet port. I have one up here if you guys want to take a look at it. Either piece after the talk, I'd be more than happy to help you out there. So that just goes right on top, and then we need software. Now, it's called Nagduino, $5 to anyone who can guess why. I lack any sort of, yes, Eric. I lack any sort of imagination or creativity, so I thought, oh, Nagios and Arduino. Got it. For copyright reasons, I'll probably change it, but it was just a good working name. So what it is a very simple quote-unquote library that makes the NRDP call for you. I do put library in quotes because, full disclosure, I'm not a developer. I'm just a geek who loves electronics. I can build things well enough for my own needs, but if I ever have the misfortune of needing to work on a public open source product, gotta help whoever has to review that code. It does not use NSCA, simply because the Arduino does not have the processing power to do the really heavy math that cryptography requires. No SNMP traps because I don't have the patience to learn them from like the networking level and build them and make them work. I did do a little bit of testing with them, and it does sort of work, but it was not live demo ready. The library is very small. Honestly, you can read it in about 5 minutes and understand it. It has one function. Instead of just making it a single function, I made it a library so I can put it up on GitHub. It'll be available after the talk. Please, 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 if you are a developer and you're interested in it, run with it. If you have suggestions, I did something horribly, or I could do something better, or here's the SNMP functionality, right? Please let me know. I want this thing to actually kind of take off, and I made it a library so that it can kind of be built on. 6 lines is all you really need to send an SNMP or a NRDP call to Nagios. It's not a lot, and I'll show you on the next couple pages here. There are no bells and whistles. I tried to keep it intentionally very simple. I didn't want to, where's my water here? I didn't want to throw too much into it. Initially, I kind of wanted to get the core functionality of it working. And for that reason, it doesn't actually check to see if the NRDP result returned valid. It wouldn't be a whole lot more to get the HTTP response from it and check it for OK or not. But I also don't have debug code. There's really no output in there that says this is working or this isn't. I do have a version that does have debug code, but it's very, very, very much my own. Meaning instead of saying this didn't work for this reason, it just says stop drinking, work on your code more. If you guys are interested, I can probably throw some of that in after the conference so that if you do decide to work with it, you can get a little bit more useful, maybe see where it's failing if it's like a network issue or maybe you don't have something hooked up. So kind of wrapping up, kind of building up to the demo here. We have input, a magnetic sensor that you might put on a window or a door. Basically, it's 2 little magnets, and as soon as they move far enough apart, something switches open, current goes through, you can sense that. It'll check it on a loop every 100 milliseconds, right? If it is open, it will send a critical to Nagios through NRDP, and it will quote-unquote latch so that you don't get 10 messages every second. It's smart enough to know, okay, I've already sent this result, don't send it again. If it is closed, do nothing. I was going to have it send a, it's okay, the window is closed message, but I found in my testing that by the time I was able to switch over and actually show you the web interface, it was okay again. I didn't want to do that. So it's very, very simple to do. It's just I didn't do it for this live demo today. If you guys are interested, again, talk to me afterwards and I'll be able to show you that. After that point, it's all Nagios. Ball's in their court. You can set up your alerts, your contacts, your thresholds, time periods, what have you. If you only want to be alerted on that from the hours of 8 p.m. to 5 a.m., you can do that. And everything after that, emails, it's all Nagios. Very familiar. So here's what I have sitting up here. This is kind of even the same color cable. So on the right, that little white thing with the 2 wires coming out of it, that's the magnetic sensor. Again, you move it apart, the sensor reads one value, you put it together, sensor reads another value. The red cable, if I believe here, that is going up to the ground. I know red is usually for voltage, but that's the color I had. And then the blue pin is just going to the sensor pin. So this is going to be the input pin that we're reading. Kind of on the top right-ish, the black cable, that's just USB, that's for power. Or if you're doing any debugging, you can do that over serial. And the blue should be familiar, that's just an Ethernet cable running somewhere off over there. So, the code, right? This is going to be 2 pages. So a little bit more complicated. Up on the top, we just include some libraries that make things easier, so I didn't have to rewrite a bunch of code. Programmers are lazy. I am no exception. We have 4 variables underneath. We have a MAC address. Every device needs a MAC. The IP is the IP of the Arduino itself. Now, in my actual demo up here, the IP addresses have changed to match what is in the hotel here. The next one is the Nagios IP address. If you're wondering why it's using commas, it's just much easier to do it that way, much smaller footprint than putting in a big string and parsing it out. And then the token, NRDP needs a token for authentication purposes. It is not encryption, so I do need to stress, don't send this over the internet. But for a small environment, if it's all internal, it'll work just fine. Standard kind of NRDP usage. 2 variables there, window close. It's just, I set it to 1 because by default it's going to start off with the window being closed like that. And then passive sent, that's the latch I had mentioned. Has it already sent off the result? The part where it says Nagduino, Nagduino, no, you're not seeing double. That's just the C++ way of creating an object. And in my case, the object is being called Nagduino. And whenever you decide to call a function from that object, it's just going to be Nagduino dot whatever. Again, I'm not going to get too heavy into code. If you have questions, ask me later. We'll just kind of continue on with the setup, which again is run one time. Serial.begin, just some debugging code to show you, yep, I sent, we're all good here. And that you can open up a terminal on your machine. It'll just run through the USB, which provides both power and data. And then you can kind of see the output there. Pin mode 7, again, is going to be the switch. It's input. We want to read it. The pull-up, don't worry too much about that. Essentially, all that's doing is it's putting a little internal resistor in there, so that's either a 1 or a 0. Sometimes electronics can get a little spooky, and things are not always 1 or 0. They can be in between. This just kind of makes sure that that does not happen. And then pin mode 13, output. Just a little LED on board for diagnostic purposes, and I don't actually use it in this code. So the loop, take another drink here. When closed, again, that's the variable, a 1 or a 0, to determine the state of the window. So we're going to read the state on pin 7. And then this is kind of the grand finale of what actually does the work. If the window is not closed and if a passive has not been sent, so there's kind of 2 ifs it has to pass, send the passive. You want to set that latch so it doesn't keep sending it. And then the real beautiful part of it is right here, Nagduino.send NRDP. It takes 4 variables or arguments. Nagduino is the first argument. That is the name of the host in Nagios that it will be sent to. The service is the living room window. This is not my living room, full disclosure. This is just a room I rent. 2 is the status, so 0 for OK, 1 for warning, 2 for critical, 3 for unknown, and a message. So the window is open, or help, we're being burglarized. If none of those conditions are true, if the window is in fact closed, skip all that, set the password to 0, make sure that we're not, leaving variables in an unknown state, and delay for 100 instead of 1,000. So we want to delay for 1/10 of a second. In my testing, I found that if you delay for a full second, you can open and close it really quick and it won't notice. If you can open and close that thing in 1/10 of a second, that's scary. You're a ninja. That's the official test. So this is my live demo, or sort of. There's a video that goes along with it, and if I can get over to that video, this is just for the benefit of the people in the back who cannot see the device sitting in front of me. So essentially what I have here is I kind of point to the device itself, networking cable, power, all that. We have the magnetic sensor, which is attached to the input pin there and the power. And I do this a few times just to kind of show you that's all it is, right? It's just a window opening or closing. And then the video goes on for an awkward 4 seconds where nothing happens. Yes, yes. And then it plays again, apparently. So we're going to go back to the interesting part. So kind of building up the suspense and then bringing it back. Tying it in with Nagios, what can you actually do? Well, a lot of graphing, right? You can say, You can take a look at if you are opening a window, maybe you can graph temperature over time versus the window state. I'm actually going to tab over here and do something a little bit more interesting before we get to that. Apparently for the live demo, you're actually supposed to do a live demo. So I'm going to. We have Windows closed on the Nagduino host for the living room service. If I do this, hopefully within 7 seconds, it's going to say the window is open. If it doesn't, I want you all to do me a favor and pretend that it did. Window is open. You ready for the best part? This phone's going to go off here and give me a text alert that says my window is open. Actually, my food's arrived. But my window is open, and you saw how quick that was. Within about 10 seconds, and the quickest I was able to get it in my testing was 6 seconds. 6 seconds from the window is open to I have an alert in my pocket. Now, if you're the building security, 6 seconds is an excellent, excellent response time for a homegrown solution. Obviously, if you're willing to pay the $1,000 or whatever, it would call the police for you and you'd be alerted right away. I think for a $50 system, that's not bad. So that was the part that has kept me awake and worrying forever, and I can move on. So, graphing. I already mentioned you can kind of graph the temperature over time, historical information, capacity planning if you're monitoring something like something that grows over time, like if you're measuring weight. So if a certain device is gathering water, I don't know, you want to see how much water is in there by weight, you can kind of get an idea of what's going to happen. I just got alerted again. I probably should have turned that off. Oh well. Multi-stack graphs for the correlations, like I mentioned. If you're running like a greenhouse for an urban garden or something, you can kind of take a look at, okay, when the window is open in summer, the temperature drops this much. Kind of interesting. Physical event handlers, I'll kind of skip over that. Basically, you could like turn on a fan if the temperature is warning, turn on the AC if it's critical, so you could kind of send that back through the Arduino itself. Use cases, I'm just going to kind of skip over those. Sorry, Sally Reich here up in the front. She did a really cool talk on beekeeping, which I did not get to see, but we had talked a little bit before the conference about how she might use Arduino to do that, right? You might want to measure the weight of the hive, so capacity planning, or the temperature inside. I'm not familiar with a way to monitor if your bears are, did you mention bears? Bear fences, which just sounds terrifying, but is definitely a thing you would want to make sure is working. Talked to Sally about that. We talked a lot about it and kind of came up with some really good ideas. Moving forward, I'd like to have NSCA and SNMP traps. That's why I'm going to open source it. The web interface I think would be kind of cool. You can actually host a website on the Arduino itself. So you could log into it, change some values. So like in winter, if you want to change the threshold for a temperature sensor, you could set that higher or lower depending on your needs. Beyond Arduino, Raspberry Pi, Dave up in the front here. You did a really cool talk last year on running Core on the Pi. The Raspberry Pi is like a beefed up version of an Arduino, right? It is truly a computer. It can run Linux, and it has the same GPIO. Bug him profusely. Yes, right there. Perfect, thank you. There's a Raspberry Pi over there if you'd like to see what it looks like. A smartphone, I'm not even gonna touch that one. You should know what that is. The Intel Edison is kind of my new geeky toy. It's coming out in, I believe, November. It is a chip about the size of an American quarter. It has something like a 500 megahertz CPU, Wi-Fi, Bluetooth, 20 GPIO pins. It is ridiculous. Check it out. It's going to be kind of the new standard in wearable tech. If you have any questions, we've got about 5 minutes left. Otherwise, bug me and we'll call it a day. Question over there?
Would you use inside the for loop on when you're actually coding the Arduino to create like a OK state so that way you can do freshness checking? Is that where you do that?
So if you're a little bit familiar with C, the way I would handle that is, okay, so you check the window, right, and it's open. What I would do is I would probably just add some code in there that sends another result if it's closed. If it doesn't get closed within 5 minutes, and the clock on this thing is not super accurate. You do have some time drift, but it's like a second every day. You could say within 5 minutes, send another result that says window is still open. Number 1, window is still open. Number 2, so you can kind of have a running total of how many passives you've received. If you did want to implement active checks, that is certainly possible. In my testing, I had basically just had this thing listen on like port 200, 2000, 20,000, whatever you want to use, and it listened for a string and it sent back a result. So active checks are certainly possible, which means freshness checks are certainly possible as well. The questions, Eric? I just answered it. Okay. Yes, sir, with the pie.
How'd you handle pull-up on your sensor?
I Googled. Essentially, so kind of going back to the pull-up thing, when I said things are either 1 or a 0, I lied. Again, talk to a politician about that. But essentially, 1 or a 0 is like a 1 is a voltage of 5 volts and a 0 is a voltage of 0 volts. Well, what if your battery is really low and it's only putting out 3? Is that a 1 or is it a 0? Well, it's closer to 1. What if it's only 2? Well, that's closer to a 0. So it's called float. Things can kind of float in between. So the pull up or the pull down resistor, there's 2 versions. Essentially, a pull up will make sure things default to 1, and a pull down will make sure things default to 0. So you know you don't have anything in between. Does that kind of answer your question? Or basically how I handled it, it's software. It's one of the states that you can do for the pin mode. So it's called input _ pull up. And it's all handled through the Arduino itself. There's internal resistors that take care of that. Yep. Anybody else or right in the back?
Hi. What about if the network cable is good?
If the network cable is good, I'm not going to cut it here myself for demonstration purposes. But as with any device, if the network cable is unplugged or cut or chewed through by bears, it won't send. Now, some of you I talked to during the conference free time know that I'm working on a wireless kind of wrist mount device. If you had wireless, you wouldn't have this problem, right? The only thing you would run into is like interference potentially, range. If somebody's microwaving a burrito, that could be a problem. But just with any other device, if the networking cable is cut, it won't work. Does that make sense? We can talk later. And Espanol, si prefiere.
Yeah, thank you.
Okay. Anybody else?
Other questions for Trevor? Any comments, questions?
Well, hey, thank you guys for showing up. This is a lot more full than I thought it would be. So I appreciate you guys all coming out, and enjoy the rest of the conference.
Trevor McDonald, thank you.